live. This is the third of my regular live streams. I'm just checking that I've actually gone live, that it's working. How about now? I've now unmuted it. Wonder if that works. I might be having sound problems. Can you let me know in the chat if you can hear me? Kind of working solo on this. It's live, that's good. I'm getting feedback that it's live. Am I audible? Can you hear me? Because I'm wondering, since I can't hear it on my end, whether I can be heard. Yes, good. Well, excellent. That's the technical issues solved. Next step, to take the tea bag out of my tea. Pop that away. And to introduce tonight's session. So, in the background, we've got printing, a couple of clips. These are filament holder clips, small little things. I've got the 0.2 nozzle on this evening, and really the point of printing these little clips that are for holding together the straight ends of the filament on the reel is just to use up the last little bit. I've got one filament which is grey, and I've only got a few strands of it left. So I want to use up the ends by printing some small little bits. So that's what's printing in the background today. And it's currently running its flow calibration. I can see there's a bit of a strand that's hanging off the hot end of the printer. Hopefully that doesn't get caught and cause problems. We can keep an eye on that in the background. But today, what I'm working on is a drainage funnel. I've been asked by my granddad to make a funnel that sits into the gutter in their conservatory. So it's a bespoke design job, and I have a little sketch here. Hopefully my camera is not filtering that out. Yeah, that's not coming into focus so well, but I have a little sketch. So just to give you a sense of the preparation that I have here, and to show you kind of how I'm designing on the fly, and just how my process is ongoing. I've done no prep for this apart from look at the sketch and made some notes of my own as to how I'm going to model this, and then I'm going to jump straight in to the CAD and start making it. So as the title of today's stream suggests, I'm going to be using Grasshopper, which is the parametric plugin to Rhino, because I want to make this design adjustable, so we can change the parameters of it, change the size of it, and customize it. Now, normally for a design this boxy, this geometric, I'd use a program like SolidWorks or FreeCAD or something. Because it's quite easy to parameterize that, and it's quite easy to use the feature tree to quickly changes. But I like using Rhino, I like using Grasshopper. It gives me a lot more design freedom. Even if for jobs like this, it could be a little bit longer. So I'm going to see if I can model this in full tonight, if I can, in an hour. And see if it can be done nearly as quickly. Let's get straight into it. I'm going to make a rectangle, and this is going to represent the kind of top opening of the funnel, and I'm going to have a width of, I've got here 4.5 inches. So let's just quickly check what that is. I probably could do it in my head, but it's late in the evening. I've already come back. This is a relaxed environment. It's 114 in case you were wondering. So I've got a slider here. This is a numeric slider. So I can pick a number from 0 to, default here is 1000. I could change that default, but I'm just going to keep it as it is. And let's stick to 114. That's going to be my X direction width. And we can see how that has, in the left-hand window with the gray grid in the background, this is Rhino. And the red lines are what Grasshopper is generating in Rhino. This is a preview. Grasshopper is what's really driving this design today. I'm going to rename this, keep things neat and tidy. Width. Copy and paste. That's Y. Obviously, that's not going to be width. That's going to be depth. And I've got here 6 inches, which if you're quick, you'll see that's 152 millimeters. Now we've got a little square, well, rectangle. We can round the corners, and I think I will do that because when we're 3D printing, it can be very helpful to have rounded corners. The reason why you want round corners for the profile of each layer is, if you imagine the printer head is coming along here and then has to come to a complete stop before then changing direction, the weight of the printer head is carrying a lot of inertia. It doesn't want to stop, and so it has to slow right down, and it comes to a stop, then causes vibration and changes direction. Whereas if you imagine like driving a car going around a bend, it's easier to go around a wide bend than it is to turn around a sharp corner. So it actually speeds up the prints by adding in those radiuses. There's a YouTube channel that's really worth looking at. I think it's called Slant 3D, something like that. He explains these things really well. I'll put a credit in the description. Now, looking at the print, just going back to the print really quickly, I can see that it's already started on one of the clips. I've got 2 clips in this print, and I've programmed it to print one after the other. That way, if it runs out of filament halfway through, I don't have two half-finished clips. I've got one complete one, and then it just won't finish the second one. So I'm telling it to print one whole model, then the next. Okay, back to the workflow. Got my top rectangle here. This is essentially going to be the entrance to the funnel. What I'm going to do is swap these around. I want it oriented the other way around. Okay, great. Now, I'm going to move this whole thing in the Z direction, which means up, down. No, that's the wrong command. In the Z direction. So this is a Z direction vector. And this function is saying take this geometry, which is generated here, and move it in that direction. And then I can give it a quantity. So I'm going to say minus 50 for now. Okay. Change plan. I'm going to copy this and then right click edit the parameters here. The minimum I'm going to say is minus 1000. We've got a much wider range, and I'm going to say that this is going to drop down by a height of height 6 inches. So negative Z direction vector means going down rather than up. Lovely. No, I want to change the size of it, but we're not going to do that. I'm going to do plane. Construct point. So I'm going to label this as origin. No, wrong side. I'm going to label this whole function as origin. Just tidy up my program as we're going along. And then I'm going to replace these. I want to change the make that 1 inch. Lovely. My 3D connection. So we've got the opening of the funnel, we've got the sort of bottom part of the funnel. This I'm going to make it a bit deeper for now, 2 inches roughly. Now we're going to loft these together, real simple. See if this works. The way that I tend to work is experimentally. I'll try something and see if it works and then try something else. I'm not often thinking ahead because it's quite difficult in this program to really think ahead with how you're going to do it. Fine. Let's just close that preview for a moment. Let's take this rectangle. I'm going to use the area function to find the centroid point in the middle. I'm going to use that to draw a circle there with let's just say a radius of 12 for now. Now what I'm going to do, because radius is a bit annoying, I prefer to think in terms of diameter. I'm going to go into expression here, put x times 2. So this is going to take x divided by 2. So this is going to take a number which I think is the diameter. It's going to divide it by 2 and then process it as the radius. So this can now be called diameter. In fact, I'm going to call it outer diameter. Whee! Lovely. Now, what I can do is take that circle. I'm going to do the move function like I was going to earlier. Take that geometry, and as we were trying to do earlier, Z, put that in there. Edit this value, minimum of minus 100. Ah, I plugged it into the wrong thing. Let's say that's going to drop by an inch. That vector into there. Now we can see that this circle at the top, which is turned green when I select it, has moved down minus 25. There. I can also move it up, but that's. So what I'm going to do is prevent that from going up, set the maximum to 0. That way it can only be either on or less. Just keep it to 50. 50. You're not listening. Ah, of course. Of course, minus 50. And we're going to loft from this curve to that curve to create a nozzle. So if I reveal the first loft again, we can kind of see how this will come together. But first problem is we've got a hole in the bottom. We've got a nozzle but no bottom. So now we've got to make a bottom. Let's close that. I type boundary edges, and I take that rectangle and this curve. So this is creating a surface based on curves that make a boundary. So it's quite cleverly deducted that there's an outside box and an inside circle, and that the red area, which is now green because I've selected it, is the new surface. So we've got the funnel, we've got the bottom part with a hole in it, and we've got the nozzle part. Lovely. So what we can do is take those three, just neaten up my space, and we're going to join VREP. VREP stands for boundary representation. Basically means box 3D shape. Select those, turn on preview. Now we have a joined together thing. Lovely. But it's a bit simple, a bit basic. What we need to do is give it some thickness. So let's try an offset surface loose. Let's see what that does. Offset distance 0. Let's set that to 3. Data conversion failed from BREP to surface. Okay. Let's turn that preview off. Let's disconnect that. Let's turn these back on. Minimum minus 10. Maximum 0 minus 3. One locally retrim off. Hasn't done a offset surface. Right. Where's that? Why is it creating these corners? Go to the radius. But well, it shouldn't. Okay. Perhaps not the ideal way of doing it, but we're going to do it. Now, so I can see that this, the bottom, as it's been offset, has actually offset outside rather than inside. So what we're going to do is take this surface and flip and put that in there instead, and then disconnect that. Let's just check on the printer, see how that's doing. Oh, I haven't run out of filament yet. That's good. A good sign. I'm wondering if this is the best method. I find Grasshopper so great a program, really good. Not the most intuitive, doesn't really fit the way that I think about it. But it's really powerful once you get going. I'm going to try this, offset B-rep. Maybe this will be a different approach. So here's my B-rep. I'm going to stick the whole thing in there. Distance to offset. Solid. Let's say that is Boolean toggle true. Do want a solid. Sharp edges. Okay, let's turn that off. What do we have? That looks like done exactly what I've done. That's thickened it. Excellent. So that is giving me a wall thickness of 1 millimeter, 2, 3, 4, 5, 6, 7. And you can see how there's a kind of funnel in the middle, which is thinner when the wall thickness is thicker, and thicker when the wall thickness. I'm going to leave it with a 3 mil wall. Excellent. Glad I found that specific. Is that one of the Rhino standard functions, or is that one of my plugins? I've got all kinds of plugins here. It could be in any one of these. B-rep, what's in there? Sasquatch. Offset B-rep. There you go. So I've got it from a plugin. Brilliant. Oh, glad I found that. You're watching this as a kind of tutorial for Grasshopper. That's not really what this is about. This is about me sharing my thought process as I'm going along my design process. Laying bare all the mistakes and frustrations, trying to model products. Now, basically this is ready, but we want to add a few more details to it. I want to add some flanges to the outside here, which can be used for mounting to the wall. And those are the radiused corners. Might be a little tricky. Let's see. Let's see. There's my origin. So the plane is here. Oh, that just rotates that way. That's not what I want. Why does the rotate plane only in the Z direction. Put the flanges on top. Yeah, that's a good idea. Good idea. Delete that. That direction. Let's take the XZ plane and let's draw another rectangle in that direction. And let's take the same width, get rid of the radius. Let's give it a new depth. Oh, wrong way. Same depth, new height. Flange height. Give it a smart name. Top. Now, it's a bit too wide. It's coming over these radius. So what we're going to have to do is, what if we just kept the same radius? Does that sort of work? Well, that kind of works actually. Does it work? Doesn't work. Because how am I printing? I'm going to print it on I think I'd actually like to print it on this top surface. So having the flange come up would be a little tricky. But if I do what we've done there and take this, I take that height, then interference on the mic apparently. Could be the fans in the background on my laptop cooler plate. That might have helped, not sure. Great getting feedback on the stream in real time. Okay, normally I'd be able to set an expression down here and multiply this by a factor. I don't know why it's not being able to do that. So let's just do it manually. Take that, multiply by -1. No, -1. This is me hacking it a little bit. Hacking. Hacking this model. Flange height. Yeah, fine. Doop, 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 doop. Addition. So we're going to take the depth thing and we're going to add 12 mil for now. And then put that in there. So it's a little bit wider. A bit wider on both sides. No. From that way. So let's move this whole thing down a bit. Room. Do the same thing here and here. All right, let's rethink this a little. Let's rethink this. I'm going to move that in the X direction by the same distance as the radius. Now the plane is going to be aligned with where the radius comes around the corner and then straightens up. And as I move the radius, the plane should move with it. Now this way, as I model the flange, let's hide that plane and do one of these rectangles. I use this plane. And I go disconnect, disconnect, disconnect for now, and I do minus 25. I keep forgetting it's 25. Edit that. Minimum of minus 100. There we go. This is doing it. There we go. And now you can see that these tabs, these flanges, are not coming from the middle of the air. They're coming from just far back enough to connect with the radius. So let's make this X height the full height, and we're going to multiply this by panel allows me just to type in my own values, so I'll put in -1, put that in, no, that's in there, so what this is doing this is taking same height as the whole thing, so the flange will always run the whole way along. As it changes, oh no, wrong variable. As it changes height, it will also, well, that's bizarre. It should be this height figure. Absolutely. That. And it's already negative, so that's much better. Glad that I tested that. Probably only need 5. Maybe a bit more. 40. If I take that, and I extrude linear, what I'm going to do is just on me offset curve. No, move, keep it simple. That in the Y direction by the same amount as we are offsetting that. And in this case, I'm going to multiply it, set the expression in here, x multiplied by -1, so we become positive again, whereas the number we're feeding it is negative. And that's going to give me these two curves, which are the same thickness as the wall thickness. As I change the wall thickness, it will adjust together with it. That's good. And I'm going to loft between first curve, second curve. That gives us some thickness. And then I'm going to cap, which means just plug the holes. I now have a solid B-rep as a flange right there. But we need some holes in it. Otherwise, how are we going to drill it into the wall? So, get rid of that cap. Let's show our rectangles again. Let's do some circles. Let's take that rectangle and use the area to find the middle. And then I can how am I going to do this? So I could put a circle with a, let's say, a radius of 2. That's a 4 mil hole. There, but you see the plane is in the wrong direction. What we need is the XZ plane with that origin in there. Now we've mapped our circle correctly. And I can adjust the size of that hole. Brilliant, but that's always going to be just in the middle. And it's only going to give us one hole on either side. I'm going to mirror this later. Perhaps that will be fine. Perhaps it won't be. Let's come up with some options. So if I do a linear array, linear array, circle, direction going to be Z, number, let's just say 2 for now. Three. That's a unit vector. So I need to define the space in between. Let's just say for now it's 15. So this changes the space in between, and this changes the number. Excellent. What I'm going to do is then use this to help generate the number of holes that we need. So that would be how I would generate as many holes as we want, and I would probably move the middle hole further down and then use that linear array. However, I've been reliably informed that's probably not necessary, and that one hole's fine. So let's stick to that. One hole there, 5 mil radius. 5 mil radius is actually quite large. In fact, this whole thing's quite large. I'm looking at my notes here, and I'm seeing that I've got my proportions the wrong way around, which is fine because I've made it fully adjustable. So 152 should be in this direction, and 114 should be in that direction. Now that's wonky. Why is that wonky? Because that should basically be the same as that. No, it should be the same as that. Lovely. I'm going to do what we did down here with this circle and make life easier for myself. Expression. X divided by 2. And then I'm going to call this hole diameter. Screw hole diameter, to be specific. 5. And 6. Let's get my caliper out, get a rough sense of how big. I reckon a 5mm hole will be plenty for a wood screw. Okay, so got our circle. Remember earlier that we took our base rectangle and we moved it forward and then we lofted them together. All I need to do is take this circle, put it into that same function, and it will do chaos. So what we're going to do this time is the boundary surfaces. Boundary surface 1 is going to be the back and that circle. Boundary surface 2 will be those. We then loft that rectangle with interesting. Very interesting. All right, let's separate out these moves then. So this is now moving the circle only, and that's now moving the rectangle only. And that allows me to loft rectangle to rectangle. And then circle to circle. So we have the wall in the middle, we have the outside, we have the two faces. We're going to take all those together, join B-rep, join them all together, hide those, hide all our lines, don't need them now. Ta-da! We have a plan. A little bit crude, but it's okay. What I might do, this is the perfectionist, is take this center point. I'm going to move it from where it is in the X direction. Point, I move it in the X direction by the same amount as the radius. Again, this has to be X multiplied by -1. What's going on here? let's change that expression by minus 0.5. Then I'm going to use this center there for the hole. See how that's now made it a little bit more central to the flange as we can see it, and not basing it on the middle of this face to that face. So we then take that and I want to flip it and mirror it onto the other side. So how do we do that? We're going to there must be a mirror. Mirror and object. Mirror plane. It's already put the mirror plane in the right place, I think. The mirror plane is going to be half the width. So we take the width no, sorry. Move the YZ plane in the X direction by it's labeled depth and mean width by expression X divided by 2 halfway. Hide that. There. Ta-da! That's mirrored it over. Lovely. So then, as I make these changes, say I want to make the hole bigger, it applies to both sides at the same time. Lovely. So, I've got this flange on the left, this flange on the right, and I've got this whole assembly here. And now what I'm going to do is merge them all together, so they make one solid, which is called a Boolean union, or solid union. Now this is a little bit unstable, so let's just see if it's off. Oh my gosh, that actually worked. That is one solid thing. We're getting close to time now, but this is looking like it could be ready. The printer has printed, and it looked like it printed both of them. That's nice. So I actually did have enough filament for that. So excellent. Might do that again next time to use it up. Let's try and get this to a point where you can see how it's going to print. So this is now modeled in Grasshopper. I might like to make some changes later on down the line, but basically we're at a point where it's ready. It's fully parametric, so we can change the size. This has got to be called width, because remember I changed them around. This one is called depth. So I can change all of these features. That was 152. That was 114. Now I can go into this final function, which is the last function, the whole solid thing. I'm going to click on the fried egg, bake. That's going to bring it into Rhino proper. So remember from earlier, this green object is a preview generated in Grasshopper. As soon as I click bake, we're now looking at an object in the Rhino program. So I can manipulate on this side. And it's exported it as different blocks. Brilliant. So this didn't work. I should have checked that. Flatten. One locally defined closed B-wrap. Bake that. I can't be bothered to explain what I just did there, but trust me, it was genius. So now, in here, I've got an actual solid thing, which can then be exported let's just stick it in here for now and I'll tidy it later. STL got a funnel V1. Yes. There we go. So that, I would say, is mission complete. If I had modeled this in a program like Fusion, it probably would have been quicker, to be fair. However, this has been done. It's been done. Watch this. Why is that? Why is that like that? Okay. Just notice this strange lip up the top. That's not going to make printing this. See, that needs tidying up. So apart from a little bit of tidying up here and there, this has been modeled in such a way that it is fully parametric using Grasshopper and can be adjusted any which way. Yeah, should be 3D printable. That's going to be the end of my stream today. Thank you very much for tuning in, and have a lovely evening. I'm going to sign out.